Where we left off, we were talking about features of depositional shores, and barrier islands are an example of a depositional feature. We talked about how there's the different parts of the barrier island where you have, walking from the ocean side, you have the dunes, and then the thicket, and then the woodlands or maritime forest, and then you have the salt marsh, the high, the low, and so on and so forth. Knowing this helps us explain why barrier islands, how we know they're moving around. So we have to talk about the salt marsh for a second. Salt marsh is one of the most productive environments. It puts down an enormous amount of organic material. When that organic material gets covered by sand or sediment, it becomes what we call peat. And in this picture that's in the book 10-10, the peat is right here. So if you're looking at the B one, in here you would have salt marsh, and as it settles down to the bottom of the marsh and gets covered over again, it forms a peat bed. The peat bed is only on the marsh side. With me so far? Over time, we've found that the peat bed actually extends all the way underneath, just like in here, all the way underneath a barrier island. And this is because the barrier islands migrate closer to shore and farther away, depending on what other processes are going on. So it's sort of like a tractor tread. What happens, so if we're looking at B again, we're in number one. We have waves and stuff that are picking up this sand and moving it this way. And the island begins to retreat towards the shoreline. And eventually, and you can see that the peat, which is staying in place, has more and more of the island on top of it. Moving this way, this is now moving this way. And eventually, you can actually see this on the Sod Banks beach on the marsh side in Sandy Hook. You will actually see peat moss washing up on the beach in the form of black sand. And this is something that you can see happening. All right, the last depositional feature we're going to talk about are deltas. Deltas are not as big a deal on the East Coast, but on the Gulf Coast are absolutely ginormous. They occur when a very large river, for example, the Mississippi, hits a wide open area. So the velocity of the river changes. And the faster and narrower a river is, the more sediment it can carry. When you're spreading all of that energy out over a large area, like in the Gulf, it dumps it. And the Mississippi River has an absolutely ginormous river delta. It's huge. It's anywhere from 16 to 50 miles outward, depending on where you go from. And this sediment is very, very fertile, and it has a lot of nutrients in it, which is one of the reasons why, if you've ever been to the Gulf of Mexico, it's actually very, very brown water because of all of the sediment that gets dumped there. That bird foot shape of sediment, we always call it a delta, but the correct term, you can see it here, is alluvium. Kind of a new word. And deltas don't always get bigger. So the Nile is one of the ones where erosion is happening much faster than deposition. The Mississippi has so much deposition that the entire Gulf Coast is actually sinking due to the weight of the sediment pushing down on the area, which is kind of interesting. Nile Delta actually doesn't have that. There's a lot more erosion. Flow is so fast. The Aswan Dam affects this as well. But the delta is actually disappearing much faster than and deposition can replace it. Beach starvation, and this picture is kind of, we have beach starvation going on here, but it's much more obvious on the West Coast. So on the West Coast, the beaches are narrow anyway. You can see them here. They're tiny, right? Not like our beaches, even smaller here. And remember, especially on these winter, summer erosional beaches like we get on the West Coast, most of the sediment is coming out of the river. And due to two factors. First is that they're damming rivers. They're damming rivers because there's problems with the drought on the West Coast, so like they're using the rivers for water and electrical generation like in Oregon. But also because, especially in California, they're lining the rivers with concrete. And that makes them flow so fast that the sediment is getting dumped out. And as you can see here, I don't know if you can see it on this picture, but there's actually a very long jetty right here. And you can see that the sand is making it, their longshore current must run this way. And the sediment is being picked up, and it's completely missing from this side. As a matter of fact, the farther you go, the more and more narrow the beaches get. What can we do to prevent it? Well, we can avoid doing all of these things. But we can also stop putting in jetties and groins. They benefit only the people that they're immediately next to. This next topic has to do with sea level change. So over time, coasts change, and some get risen up. We call that an emergent shoreline, and some sink down. And these happen all over the country, and it's due to multiple things. Yes, there's actual changes in sea level, but it's also due to coastal geomorphological as well as tectonic, and we'll talk about isostasy and changes in a minute. So when you have an emergent shoreline, that wave cut bench that was underneath, that was covered with sand, gets lifted up. And this is usually due to tectonic activities, though it can also be due to isostatic rebound. And the evidence of this is what we call stranded beach deposits. We actually get things, shoreline sediments like crushed shell, sand, whatever. They get stranded above sea level, and these occur in a bunch of really weird places. There's actually some left over from the inland coastal sea in the Midwest. Submergent features are actually drowned beaches where you have lots of sand offshore, like we have. And you also get what we call drowned river valleys, and which is, instead of being like an estuary, this used to be a river valley. And you can see this in the Chesapeake. Parts of the Chesapeake actually have fossilized trees along the shore that are actually quite a bit below sea level because this used to be a river valley. The trees were next to it, but now due to the fact that the whole coastline is sinking, it's now underwater. So let's talk about these changes in sea level. One of the most drastic one is going to be due to plate tectonics, and they can either uplift entire coast like it happens with fjords, or they can drop down. And this is the whole notion of California is going to fall into the Pacific. So plate tectonics can have a huge effect on the level of the ocean in relation to the crust. So on the Atlantic coast, we're dealing with issues from spreading centers, and on the Pacific coast, plate collisions and faulting are the bigger factors influencing tectonic movement of the coastlines. Isostatic adjustment, please make sure you know what this is. This isostatic adjustment, remember, the plates kind of float on the magma. And having something heavy on top of the plate, just like you have a floaty in the pool, will push it down, and the crust will actually sink. And the most common cause of this, so there are other ones, but the biggest one is glaciers. When we have periods where we take large volumes of water out of the ocean, freeze them on ice, and stick them on land, causes isostatic adjustment downward. The crust will actually sink. And then when you remove it, frequently when the glaciers either retreat or fall off, you get isostatic rebound where suddenly and we're talking geologically suddenly, the crust bounces back. And there's actually really strong evidence for this right around here in Hudson Bay. When the Wisconsin glacier retreated 100,000 years ago, the bay itself and the whole area around it actually moved up 150 meters in a very short period of time. And we can see this all around, that sea level change was very, very quick. There's a place in Europe, I think it's Europe, maybe Russia, Gulf of Bothnia. Oh, wait, no, that's way North Europe, where the isostatic rebound was 275 meters. So glaciers are the main ones. There's a couple other things. Volcanism can actually cause the crust to sink when you have a whole lot of magma. And also landslides in areas like right along coastal plates that can also have it. So isostatic adjustment is the second major cause of sea level change due to movement of the Earth's crust. Eustatic. So obviously it's a little confusing. Eustatic is changes in the volume, changes in coastline due to changes in the water level. And these can actually be due to the actual change in volume. We have thermohaline issues going on where the ocean is heating up, and you know that seawater expands. So seawater is, the oceans are expanding due to that. There can be eustatic changes from things like climate change, changing the amount of water. One of the ones that kids always get stuck on is spreading rates. If you're taking, the basin, the tub that the water is in, and you're moving it, you can either do two things. If you're moving it very fast, or even if you're moving it very slow, you're changing the volume of area that the water can go to. So if you make the tub basin wider, you're going to lower the level of water that you see on the coastline. And that's basically what eustatic changes in sea level do. We know sea level has changed. During the Ice Age, it was significantly lower. Our coastlines went all the way out to the continental shelf, basically in New Jersey. And after the last Ice Age, it began to come back up. We're sort of at we should be at basically the glacial minima, which is when sea level would be at its highest, but it's still getting higher. And the concern for this is now climate change. But be aware, sea level has risen and fallen with the ice ages naturally over the last millions of years. This graph is one of the more conservative ones, and it scares the crap out of me, and maybe it does you. I don't really know. So just since 1850, sea level has risen 40 centimeters, or almost a foot and a half. That's an old number. That's probably 2 or 3 years. Just since Sandy, sea level's probably gone up an inch or two, just in the last 2 years. And sea level is going to continue to rise, not just because of, melting ice caps, but because the heating of the seawater itself is going to cause, as the ocean warms up 1 or 2 degrees, the amount of volume that will increase is actually really not well known. It is entirely likely that in your lifetime, Sandy Hook will be an island again and or underwater at every high tide. And this is sort of the big scary for those of us who know a little bit about climate change. Am I going to skip this one? This is just about erosion and how it's not equal all over the country. We'll skip this slide. And I think that's it. So 12 minutes, not that bad.